So waiting for you to start teaching.
Oh, evening. How are you?
Evening.
Fine, fine. How are you?
Fine, fine. Okay, so we can start. Okay, so I don't know. I'm sure you've noticed that the camera is not straight here, and I'm sure, but we're going to see what we're going to do. Case. Hello, is everyone getting me?
Yes.
Yes.
Okay. So today we look at linear functions. So let's look at a definition.
How is the
Let's
screen?
make sure my handwriting.
The screen seems to be upside down.
Yes, that's what I was trying to say. Just find a way of how you can see clearly. If it means turning your phone, but this is the best way I can put my camera. But I'll try to sort this as we proceed. Okay. Yes, so I think we can start. Function is simply the function f of x equal to x plus b. So you have something like that. So that's how you define a linear function. A linear function is f of x is equal to ax plus b. So where we have that, where a and b that's what we have. So we have a and b being function. So when you talk about linear functions, we simply mean when we try and plot the graph of this function, we are going to obtain a line. It is simply a straight line. That is why it is called a linear function. And it is written in this form. That is how you express a linear function.
Hello.
So let's look at an example.
All right, all right. Okay. All right.
Look at an we have something like that. F of x is equal to x plus 2. So this is a function of x, which is a linear function. So something like this one is also a linear function. F of x is equal to x plus 2. So we also have that. That is another example of a linear function. So as simple as that. So for simplicity, you can simply let so you can get this f of x equal to y. I'm sure you going to see some things like, so this f of x equal to y like this, x plus 2. So we are talking about one and the same thing.
Oh, ati wasiana na bwana Dimai.
So having so since we find a linear function, which is this, so this is what we're going to do. That is a function. So we can look at the domain and range of function.
Up to this orange test. Oh my God, mute
Is
yourself.
everyone able to see what I'm writing here? Are we following people?
Yeah.
We can't hear what you're saying because of the person that's like flashing.
Huh? Someone
Yes, sir, we can't get what you are saying.
I'm asking to say, is everyone able to follow? Some people are making noise.
In class. All right. I think it has image up.
So let's continue. We will look at the domain and range of a function.
Oh, sorry, Mr.
So let's look at the definition.
Moses, please mute your mic.
Yes, so we are defining what a domain and range of a function is here. And we're saying the domain of a function is simply a state of all possible input values. The values that you put in a function, that is what you call the domain. So it is simply a set of all possible input values. Then in the range, we have that. We have the range of the function. So it's output. The values that you put in a function, and then the values that you obtain after solving for a certain value in the domain is what you call the range. So it is also a set of values. The domain is a set of values, and the range is also a set of values. So let's look at an example just for us to understand what we are talking about here. So we have an example here, 3 examples. You can't see even now.
Okay, yeah.
Now we can see.
Now it's clear.
Okay, I'll
But
be doing that.
again.
Okay, I have a bit of a problem with my camera, so I'll be doing that. After I write something, then I do that so that you see.
Okay, should
All
I-
right,
We'll
sir.
sort this out. Yes. So I have three examples here of functions. So the first example is saying copy and complete the table for the function. So the first one is we have a function f of x is equal to 6x plus 2. And then we've been given a table of values here. So in the first one, we have the x values. We have -1, we have 0, 1, 2. So for us to complete this table, we've been given the x values and the function here, which is 6x plus 2. So what we are going to do for us to complete the table, you simply get this function here. So we have f of x being equal to 6x plus 2. So in the first set of values, we have x value as -1. Then the y value we don't know, so we have to stop it. So we are taking the y as f of x in this case. Are we together? So the y here is our f of x. So we are going to have that f of -1 is equal to, you plug in where there is x, you put -1. So you have 6 by -1 plus 2 there. So you get, what is 6 times -1? You get -6, then plus your 2 there. So you're going to get -4.
The party of Sunday morning.
Okay. Are we able to see now?
Yeah, better.
Yeah, sorry, I'll make sure I'll work on this tomorrow. By tomorrow, I'll work on this.
All right, sir.
Yes. So we have our y value here as -4. So that is -4 there. So -1 is pairs with -4 there. And then for the second value here, which is 0, which is the x value. So we do the same thing here. So you find f of 0. So f of 0 will be 6 times the 0 plus 2. So what are we going to get there? 6 times 0 is 0, then plus 2. Then you're going to get 2 there. So 0 is 2 there. 0 is going to pair with 2. Then you also here you find f of 1. Here. Let's do it here. So you have f of 1 being equal to 6 by 1, then plus 2. So you're going to have 6 times 1, you get 6, then plus 2, you get 8. So that's what you get when x is 1. And then for the last one, 2, so you simply find f of 2 there, which you're going to get 6, where there is x, you put 2, and then you're going to have plus 2 there. So 6 times 2, you're going to get 14. So the y value when x is 2 is going to be 14 there. That's what you get. So I'll give you an exercise. Try to plot the graph of this function. You're going to see that we are going to do one. We're going to plot one so that you see that it is going to come out a straight line. Are we together? So that's why the linear function, it is simply a straight line. And then for this one, do we also need to do the second one?
Yes.
We do the second one. Okay, let's do it on another paper. So this is the second one here. By the way, are we done with the first one?
Basta filis paper for cara idea.
Okay, we're doing that. So let's just try to copy B. Just copy B so that we can follow it. Copy this one. So if we get back to our definition of a linear function, what did we say a linear function is? So I said it is a function of this form. So we have ax plus b. So in this case here,
So
b
we
is
can't see anything.
That's going to be a problem now. It's becoming serious.
Kasanga machapa nsena pafita so tature mwana buno.
Na bara ndati ni kamera ya butaidi bwino sana. Tamufire.
Oh.
Yo, I was not in neighbor.
Raymond, we all know it's you.
Yeah, was a mambo costa.
Akano amo kutaxinga batuta so kura skill.
Okay, just try to follow, but I can see from my camera here. If you pay much attention, no, like I'm going to see on the camera. So if you try to pay attention, you're going to see.
Basa, me have been paying attention to it.
Personally, I can see.
So when I do that, that's why I have to see now.
But you can't see anything.
It's getting clear after some time again. Yeah, where that becomes clear.
Okay, so we're going to work on that. We're not going to experience this in our next video.
But me, I can see, but I don't know why you are complaining.
Some people can see.
I want to run my body now.
Okay, so guys, we're saying, so we've talked about, we've defined what a function is, a linear function in this case. And then now we've talked about the domain and the range. So we said the domain is simply the set of all input values. So the domain is independent. You can pick any numbers, any number you can pick, that's the domain. And in this case, we were given. So in this case, in the first case, the domain is -1, 0, 1, and 2. That is the domain of this function, the first function here. And then the range, we said it is the set of all output values, the numbers that you get after solving for the values of y using the values in the domain. So in this case, when we had x as -1, we got -4. So that is -4 is in the domain, in the range. Also 2 is in the range of this function. 8 is in the range. 14 is also in the range. So in this case, the range of the domain of this function, you can say for the first one, so the domain is simply, you have -1 there, we have 0, we have 1, and 2. And then the range we have of the first function range is -4, you have 2, you have 8, you have 14. So that is the domain and the range of our first function. So the second function we've been given as f of x. I don't know if you've copied this. F of x is equal to -1/4x minus 2. So let's solve for b here. So b, we have f of x is equal to -1/4x minus 2. So we are dealing with this one here. This one. So what are we going to do for us to find the values of y here?
Just write the values of x.
Yes, simple. So let's plug in the values of x. In this case, the table we've been given. The first value of x is 0. So you find f of 0. So f of 0 is equal to 1/4 minus 2. We get -1/4 times 0, you get 0 minus 2. There you get -2. So 0 is going to pair with -2. And then for the second value, we have f of 4, which will give you -1/4 times x, which is 4. Then we have -2 there. So what is -1/4 times 4? You get -1 minus 2. Then this you are going to get -3 there. So that is the value of f of x when x is
No, big up.
again here. The next value is 8. So you find f of 8. So this will be equal to -1/4 times 8 minus 2. So this will be -4 into 8. You are going to get 2. Get -4 here. Then for the last one,
Guys, switch off the microphone, then you continue with your conversations.
Yeah, serious guys.
And if they don't want to learn, please let them leave the meeting because some of us are really interested.
Serious.
okay, so here f of 12 we are going to get, we have 4 into 12, you get 3 times -1, you get -3 minus 2, which will give you -5. So here when you complete the table, so the value of y when x is 0 here, we had that it's -2. Then the following value had to be -3. Then the following value would be -4, -5. So for this function, the range is what you've been given, and then the domain is what you've been given, and then the range is what you get after solving for the values of y. Are we clear on that one? So on linear functions, there's nothing much to know apart from the domain. You also need to know that you obtain a line. So let's try to just plot the graph of one function here. So we're going to leave C. People can do C as a task. Just try out C. So we have f of x being equal to 1.5x plus 3. I hope people can see that. Just try to copy that one.
We can't see, sir.
Sir, please focus it again.
Yes, I'm trying to focus it so that people can see. Oh, okay. I'll keep on doing that until people can copy.
That's clear.
Okay. So that's copy C. Right.
Again, Daddy.
Have we copied that one?
No, sir.
So let me just say it out. Have we copied that one?
Sir, I have a question. Yeah, as other moments where we can be given funding and then have to find a domain.
Sorry, I can't get you.
So as I'm saying, as do you have situations where we can be given a function and then we're asked to find the range and the
Yes,
domain?
we have such situations, and this is what we are doing. So you can be given a function, then they ask you to find the domain, but the domain is independent. So in most cases, if they want you to find the range, they give you the domain, and then they ask you to find the range.
Oh, okay, thank you.
Yes. Yes.
I don't know. I'm not able to see clearly. I'm asking if you can focus the camera.
Okay. I've done that.
Thank you.
I want us to try and plot the graph of this function. We are going to do, okay, for the graph of, let's do P. Let's plot the graph of P so that we see what we're talking about, so that we now fully explain what linear function is. So we are going to do it on a Cartesian plane. Something like that. So we are going to name this the x-axis. So where we're going to have the values of x here in this axis, and then let's have that as our y-axis. We are going to make subdivisions on both the x-axis equal. Just make sure they're equal. So if you choose, for example, to divide this, if you choose maybe 2 centimeters each division here, just make sure it's 2 centimeters throughout the y-axis. And say if you choose 1 centimeter on the x-axis, just make sure each division has 1 centimeter. Are we together? Or you can use the same scale on each axis. So for example, so I'm going to assume that my divisions here are equal. So like that. So where the 2 lines meet, that's where you have your 0, that's the starting point. So we have your 1 there, your 2, your 3, 4, 5, 6. Okay, so the x-axis goes up to 12 positives. Seven, 8. Then we have negatives on the y-axis when you look at the function here. So the range is -2 to -5. So you can say that's your -1, your -2, -3, -4. So we have -1 there, -2. Okay. So you have -3 there, -4, and -5. Okay, I don't want to concentrate on the positives because on the y-axis we only have the negatives, and on the x-axis we only have the positives. So let's just concentrate on the positives and the negatives of the y-axis. Are we together? But you can still go on and subdivide the positive part there and the negative side here. So let's look at the table values that we have here. So we have that when x is 0, y is -2. So when x is 0, y is -2, -2 is here. So when x is 0 here, y is -2. And when x is 4, we have our 4 somewhere here, then the y value is what? -3. So it's going to come somewhere there. 4,3. Somewhere there. So as a matter of fact, when you're dealing with linear functions, when plotting the graph of a linear function, 2 points are enough. If you are accurate, you find that when you join these 2 lines like this, I don't have a ruler. So like that. Okay. So you can do that. So that is the graph of f of x equal to, this is -1/4x - 2. So that is the function there. So you can try out, so once you've drawn this line, you can try out the remaining points. You see that they'll fall on this a uniform grid with you. So let's try this one. We have 8, -4. So we have 8 there, and then our -4 is somewhere there. You see that they are going to meet somewhere just along the line there. So this is the graph of the function f of x is equal to -1/4x - 2. Any questions so far? Hello?
No questions, sir.
Any questions?
It's clear, sir.
It's clear, sir.
Yes, so that's what you, so you can try to do what you've just done here with the remaining ones, including the one we left as a task there. So it's just a straight line. A linear function is simply a straight line. I think we can go back here. There's something that I want to make mention. Okay, so let's get back to the definition of our what a linear function is. So we say the function of this form. So we have f of x being equal to ax plus b. Now, when you look at our example, when you try to compare this, so in this case, if you try and see, our a in this example is what? In this example we had here. So this one is in standard form. This is the standard form of a linear function. So our a in this case is -1/4. Then we have the x, then plus b. The b is a negative number. That's why we have a -2 there. Another thing that you need to know about a linear function is a linear function has a gradient. So it's, for example, this one, you see it is inclined at a certain angle. That's what you call the gradient. Then the gradient of a linear function is simply this one here. The a, that is the gradient of the function. So that is the gradient of the function. And then the b, if you notice here, the b, we have this function f of x being equal to -1/4x minus 2. This is the -2 here. And then we see that this function cuts the y-axis at this very -2. So this -2, or the b here in the general form of a linear function, is what you call the y-intercept. That is what you call the y-intercept. And then a is simply the gradient of the function given. B is the y-intercept. So I don't know if you can be asked anything else apart from finding the range of the function given the domain, and then how to plot the graph. Sometimes you can even be asked to find a solution from a graph, which is very simple, guys. So for example, let me tell you this. This is the function f of x is equal to -1/4x minus 2. See there? So for you, when you're asked to find, for example, the value of the y when x is 2, you can simply use this graph to find the graph, the value of y. So you can use the graph to find the value of y given any number from the domain here. So for example, f of 2, you simply go down like this. So where you're going to meet the line, you go to the y-axis. So you're going to discover that f of 2 is somewhere here, and the y value will lie somewhere there. If you try to find f of 2, in this case, it's going to be a decimal number, isn't it? So that's why you see it's being negative. So you can use the graph to find the values of y. I think there's nothing much to know about linear functions apart from knowing the general form of a linear function, which is simply x plus b. That is the general form of a linear function, where a and b are constants. What do we mean by constants? If you look at this example, f of x is equal to x plus 2. This 2 doesn't change, it's a constant. And if the coefficient of x there, in this case it is 1, it's also not going to change. And 1 and 2 are real numbers. That's why we say where a and b are real constants. So that's what you need to know. So it is written in this form, that's a linear function. An example of a linear function is here. We have two examples. F of x is equal to 2x plus 2. F of x is equal to x plus 2. So don't be confused when you see something like y is equal to 2x plus 2. We're still talking about one and the same thing. The only difference is that here the f of x has been replaced by y.
Sir, I have a question.
Yes.
Does it mean that linear functions are always added with a 2?
No, it's just a coincidence that we have two linear functions which are added by 2. So a b, when I say it's constant, I don't mean, so we have different linear functions. You can have a 5 here. You can have a 3. You can have any number. But in that function, when you have a 7, the 7 is constant. When you have a 5, it is constant. When you have a 3, it is constant. Is that clear?
So what you're saying is that what differentiates linear functions to others is that linear functions, what can I say? You have to add something like the formula, the general formula, which is ax plus b.
And that is why we've defined the linear function like this. So when you see any form of a function, any function in this form, that is a linear function. So sometimes we have, so this is the standard form of a function. So sometimes it cannot be in a standard form, but you have to express it in a standard form so that you have the gradient and the y-intercept there. But the general form of a linear function is simply f of x equal to ax plus b. That is what we have. And the graphing of linear function, guys, very simple. It's very simple, just like this. So you are given a table of values. Just look at the table of values and pair the values. Just don't try to mix the results. So if it's 0, you have to solve for y when x is 0. Then you have a pair 0, -2. That's how you graphing a linear.
Excuse me, sir.
Okay.
Yeah, so like what a case where, for instance, we've been given an equation, then there's no constant. Let's say the constant b is not there. Is it still a linear function?
Pardon?
For instance, for this equation, let's say we have just been given the first part and there's no constant b there. Yeah, the one you are showing here, sir. Like,
b. So you are saying something,
yeah, there's no
like,
constant b.
Say you've been given like something like 2x, not so?
Yes. So yeah, is it still called the linear function?
Yeah, this is a
No, sir. Let's go with. Wait, sir. Sorry to disturb. Let's go with 1/4 and then x. Can that be a linear function or what?
Y equals 1/4 then x.
Yes.
Yeah, that's very much a linear function. Why? Because we have something like that. And this will become your B when you compare it to how we define the linear function also.
Okay, sir.
So this was the linear function. I don't know if that's clear.
Yes, it
Yes,
is.
it's clear, sir.
Okay. So any questions?
No question, sir.
Okay, let me just give you something to do here. Let's say, so we have a simple task here.
Sorry, I have a question.
Is that a question?
I'm actually going to take back to the domain and the range.
Hello?
Hello?
I engage you.
The question was about when finding the domain and the range. So, like, how can we find the domain and the range of a radical function? Take, for instance, f of x is equal to.
We are talking about linear functions here. A radical function is not a linear function. That's not a linear function. Yes. But you can use the same approach to find the radical. But you just have to know that a radical doesn't take, for example, a square root doesn't take negative numbers. So you can't include negative numbers in the domain. Not so. Are we together? Are we clear?
Yes.
So yeah, A as f of x being equal to 2x plus 3. Then you complete this step here. I wish people can see.
Commander wants you.
these two questions. So, okay, let me add one more question here. I want you to tell me the function, and let me add the question here and find the Y-intercept. Intercept. So for this one, I want you to find the Y-intercept. Even for this one, find the Y-intercept here. Then for practice, please just try and graph these two functions here. So we've done an illustration of how you can graph a linear function. So if you don't get a straight line, then what you're doing is not correct. So the graph of a linear function is always a straight line.
So can you kindly focus the camera? I want to copy.
Okay, sure. Okay.
Thank you.
Yes. Okay, I'll keep on doing that. So, so don't forget a domain. Remember, the domain is very independent. You can pick any numbers. Just be mindful of how you pick the numbers. When you look at the equation, it can direct you how to pick the numbers, but you still get a straight line. So the domain is independent and the range is dependent on the numbers that you pick in the domain.
So the domain are always numbers from the x-axis.
Yes, the domain is simply from the x-axis.
Okay.
Yes. We're remaining with 3 minutes. Are we done copying?
Yes, sir.
Everyone?
Excuse me, sir.
Huh?
As we meet next time, are we Are we going to do on the same topic or maybe to do another topic?
We'll see. Maybe if we can look at systems of equations, but I don't think that will be. I'm sure we're going to look at other topics as well. But if I feel that I'm not done with this one, then we can still get back to it.
No, okay.
Yes.
No, okay, thank you.
So otherwise, that's all we had for today. So just remember the definition of a linear function. The domain is simply the inputs, the set of input values, and then the range is simply the set of output values.
Thank
So
you.
that's it. It's a very simple topic, very simple. All right, everyone, enjoy the rest of your evening.
Thank you so much.
Thank you, sir.
Welcome. See you next time.